again. For our next presentation, I want to welcome to the stage Jen Winters and Teresa Patterson, two of our watershed managers, to talk about America's next top living hydrology model.
Hello, everybody. How are my peeps today? All right. So Jen and I are here to tell you about the next, the living hydrology model. And in the spirit of being a little cheeky, we're going to try to make hydrology sexy. Starting out, you're like, how many, right? How many of you imagined a supermodel on the screen during an MHFD presentation, right? We'll start there. So just so you guys know, well, many of you do, I was the Northeast Watershed Manager for many, many years. And in September, Jen Winters joined us. And in the spirit of that, of this transition, we're going to tag team our presentation today. So the district's been working on several different living hydrology models. We're going to focus today on the First Creek Watershed as a pilot project and tell you a little bit about what we have been doing and what we're getting out of that effort. First, I want to thank the Aurora and the City and County of Denver for being the local governments that are on this ride with us. And then also want to thank RESPEC, who Jen started this project with me as a consultant, and now she's managing it on this side. So thank you to everybody on that. So why might we want to do a living hydrology model? There were two things that we really wanted to get out of this effort, and one was, is a living hydrology model a good idea for the First Creek watershed? And two, is this a good idea for other watersheds as well? So those are the two things we're trying to primarily get out of this effort with a living hydrology model that is updated with updated land use as development occurs, putting in regional detention, seeing how that functions. In the First Creek watershed, just so you guys know, it's a long linear watershed, about 50 square miles in the northeast portion of the district. It outfalls to the South Platte River in Commerce City. We're mostly going to focus on what's going on in the upper watershed. It goes through 2 counties, 3 municipalities, and the Rocky Mountain Arsenal. This is a very dynamically changing watershed. There's a lot of development that's occurring in this watershed. Those blobs in red is where development had occurred previously to 2017. And in 2020, you start to see those red polygons with the yellow around them. In 3 short years, we started to see development start to pick up. But then in 2 years later, just 2 years, we're now seeing that a lot more of development in the watershed is happening. And I will tell you that this is already outdated. I was looking at this last night and I was like, ooh, we could have added a whole bunch more blobs on there than what we're seeing. So it's really quickly changing. And with that, we have known that this watershed was going to change a lot. In 1990, we studied the First Creek watershed, and in place, we put an IGA between Denver, Aurora, the Mile High Flood District, and 2 metro districts to ensure that as development occurred, we wouldn't exceed the peak flows that were planned in this master plan. But since then, we've continued to study it and continued to study it and continued to study it because we knew that it was important to keep a handle on what was happening in the watershed. The latest one is an ongoing study with RESPEC that Jen started, where it's a master plan for the downstream area in Commerce City, but we redid the hydrology in the entire watershed. And from that study, we've been working on the living hydrology. In the IGA, we have several locations throughout the watershed that we're targeting and really keeping track of the peak flows. 3 I just wanted to highlight was First Creek, where it crosses I-70, and then 2 locations where First Creek and Trib T cross Piccadilly, because that's the boundary between Aurora and Denver. So in an ideal situation, when you're talking about regional hydrology to control and mitigate for development and the increase of runoff and peak flows from development, you'd like that to happen from downstream to upstream, right? Happens downstream, it's very predictable what the upstream flows are coming onto the site, and you know how to control for those. But, show of hands, has anybody ever seen development always occur from downstream to upstream? Nobody? In actuality, it happens very much like scattered throughout the watershed. And so there's a ton of uncertainty for us as managers of that peak flow control that we just felt we were missing a tool. We were missing a piece to the puzzle of, are we accepting proposals that actually hit the targeted peak flows that we're looking at? And do we have a good handle on how the watershed is developing and not causing a problem? And so with that, I'm going to hand it over to Jen, and she's going to actually tell you what we're doing.
Thanks, Teresa. Okay, so how are we using the living model? When we started the pilot project, we had identified 6 project goals. Really, number 1 is what we're talking about when we talk about a living model, so maintaining up-to-date hydrologic models. The other goals are more like what we do and what we learn from the process of doing, number 1. And at this point, we have achieved most of these goals, and it's not really a pilot project anymore. It's a real tool that we're using to manage First Creek. So when we talk about updating, update hydrologic models, we're talking about updating the models that we would normally do with the master plan, the MDP. So updating the existing conditions model to represent as-built conditions for regional detention or land use changes, and then also updating the master planned conditions model. So updating it for as-built conditions, but also for changes in proposed conditions. So for example, changes in locations where regional detention would be located. And really how we've used this so far is with the development review process. So whenever a development engineer is proposing a new regional detention facility, we obtain their CUHP and SWMM models, plug those into the living model, and check out the results in terms of the regional impacts. And then we provide the summary in some kind of memorandum that goes along with our typical development review comments. And really what we're trying to get at here is to answer 2 questions. One is, are the peak flows leaving the site appropriate? So are they hitting the historic peak flow requirements? Are they hitting any master plan peak flow requirements? And then also, are we inadvertently increasing peak flows downstream of the project site? So Tyra wants to know why we can't just look at the project site itself. As Teresa kind of alluded to, the hydrograph timing for First Creek specifically is very sensitive, and it's partially due to the shape of the watershed, it's partially due to how the tributaries enter the watershed, and it's also partially due to just how much existing and proposed detention is in the watershed, making the timing of all the hydrographs very sensitive. So this is just a really quick example of impact that like 30 minutes could have. This is an example of a confluence with the tributary in the main stem. So yellow and blue make gray. So just delaying that 30 minutes can cause a big impact to peak flows. We've used this on several developments so far. We've been using it since 2021. And we've really found that this is a great tool to help manage peak flows in the watershed, especially as it's actively developing. So what's the future? How are we going to use these from now on? We've learned a lot of things. Not all of them have been super rosy. There have been some challenges. There's a lot to manage. There's a lot of files, results. Development, understandably, isn't waiting on each other to build the regional detention ponds. So there's a lot to manage in terms of just the traits of the model itself. But there's a whole lot of benefits. Again, it's a great way for us to manage peak flows in the watershed. It allows us to be better stewards of the stream by giving us real peak flow values or more realistic peak flow values to help us do design and size our infrastructure downstream. And maybe one of the most important things is it kind of gives us peace of mind. Like in the past, we would have just restudied the watershed in 10 or 20 years and just crossed our fingers and hope that we got good results. But now we can keep track of current and proposed conditions in real time. We have 3 other living models that I'm just going to touch on really quick. So the Second Creek living model, which is a spin-off from the First Creek living model. As you might have guessed, it's the watershed right next to First Creek and has very similar kind of traits and problems. So if you're interested in that living model, contact Andy Stewart. We have the Highline Canal living model, which is a bit of a different thing. It's a living model used to analyze the capacity of the Highline Canal for stormwater quality and conveyance purposes. If you're interested in that one, check out the website or contact John Billines. And then lastly, Bruce is going to be talking in about 60 seconds about the real-time rainfall runoff models that we have at the district, so stay tuned for that presentation. So, in conclusion, Teresa and I both make really good Tyra banks, and also living models are really good so far for First Creek. They're really good for Second Creek. Are we going to use them in your watershed? Maybe, maybe not. It all kind of depends where the benefits outweigh the challenges. Thank you.